Hello students, welcome you all. Welcome to this YouTube channel. You are most welcome. So today let me discuss the strain gauges. Strain gauges. So strain gauges are used for the measurement of strain and stress. So when any conductor is compressed or elongated, then its resistance changes due to the change in its diameter and length. Also, there is a change in the value of resistivity of the conductor, which is called as piezoresistive effect. Alright. So, strain gauges are used for the measurement of strain and stress. When any conductor is compressed or elongated, then its resistance changes due to the change in its diameter and its length. And also there is a change in the value of resistivity of conductor, which is called as piezoresistive effect. Right? So strain gauges are used for the measurement of strain and stress. So this is the original conductor wire, which is having length L and diameter D. So when I am elongating this conductor like this by applying force F on both ends, so it will be elongated by length delta L on both ends, and the diameter will consequently shrink, it will decrease from D to D minus delta D. Right? So basically I am elongating the wire, the conductor wire I am elongating. So due to this elongation, the length of the conductor will increase and diameter of this conductor it will decrease. So length will change and diameter will also change. So due to change in its diameter and its length, the resistance of the conductor will change. Right? So I will go the derivation in total 5 steps. I will give you 5 steps. In 5 steps I am going to do the derivation. So I am taking step number 1. R is equal to rho L by A. That's a basic relation. R is the resistance of the conductor, rho is the resistivity of the conductor material, and L is the length of the conductor, A is the area of cross section. A is equal to pi r square. Right? So differentiate this R is equal to rho L by A with respect to surface S. S is the surface of the conductor. So del R by del S is equal to, I am differentiating right hand side. So I am doing the partial differentiation of rho, partial differentiation of L, partial differentiation of A. So in the very first term I am writing rho by A. I am taking outside this rho by A and differentiating this L with respect to S. So del L by del S minus rho L by A square. See, I am differentiating 1 by A or A inverse. So A to the power minus 1, when you differentiate it you will get minus A to the power minus 2. So that means rho L by A square del A by del S plus, take L by A outside, right, and here you will write del rho by del S. Right? So now divide this whole equation by R is equal to rho L by A, right? Divide this by R is equal to rho L by A. So divide left hand side by R and divide right hand side by rho L by A. So when you do this, you will get 1 by R del R by del S, right? And right hand side divide by rho L by A. Divide each term by rho L by A. So here rho by A get cancelled, you will get 1 by L del L by del S. Here rho L by A get cancelled, you will get 1 by A del A by del S, plus here you will see that L by A get cancelled, and here you will get 1 by rho del rho by del S. That is equation number 1. Alright, okay. Now step number 2. Step number 2, take A is equal to pi R square. A is equal to pi R square. A is equal to pi R square. Small r is the radius, which is equal to diameter by 2. Half of the diameter is radius. So here I can write pi d square by 4. D is the diameter. So differentiate it by surface S, partial differentiation. You will write del A by del S is equal to pi by 4 d square. When you differentiate it with respect to S, you will get 2d into del D by del S. So divide this whole expression by A is equal to pi d square by 4. So when you divide this divide this by A is equal to pi d square by 4, you will get, see, left hand side you divided by A, right hand side you divided by pi d square by 4. So you will get 1 by A del A by del S and 2 pi d 2d del D by del S, or 2 pi d by 4 del D by del S divided by pi d square by 4. You will get, see, pi d by 4 get cancelled, numerator and denominator. Pi d by 4 is common, so it will get cancelled. So you will get 2 by d del D by del S, right? So now put this 1 by A del A by del S is equal to 2 by d del D by del S in equation number 1. So here in this equation number 1, here in this place you put 2 by d del D by del S. In place of 1 by A del A by del S in equation number 1, you put 2 by d del D by del S. So from equation number 1 you will get 1 by R del R by del S, right? 1 by R del R by del S is equal to 1 by L. Let me call this step number 3, right? Step number 3 is 1 by R del R by del S is equal to 1 by L del L by del S, minus put this 2 by d del D by del S plus 1 by rho del L by del S. This is added as it is. So simply in place of 1 by A del A by del S, you put 2 by d del D by del S. That's it. Let me call this equation number 2, right? So that is step number 3. Alright. Now step number 4. In step number 4, let me introduce Poisson's ratio. Let me introduce Poisson's ratio, Greek letter. This is a Greek letter. I am representing this Poisson's ratio by a Greek letter. This, it is just like a small v of English letter alphabet, right? So Poisson's ratio is equal to lateral strain by longitudinal strain. So lateral strain means in this direction, right, along the diameter. Lateral strain means along the diameter. So lateral strain means del D by D, that is the lateral strain. That is the lateral strain, that means along the diameter. And longitudinal strain means along the length. Longitudinal strain means along the length. Longitudinal strain means along the length. So that is del L by L, right? Now you see that there is a decrement in the diameter. When you elongate this conductor, there is a decrement in the diameter, that is d minus delta d. So represent this decrease by a negative sign. So I am representing this decrease by a negative sign, minus minus shows the decrement in this diameter, right? That is a lateral strain, that is minus del d by d divided by del L by L, that is equal to Poisson's ratio, right? Now from here you will calculate del d by del L is equal to Greek letter, this looking like a V, right? So here you write it Greek letter into d by L minus sign, right? That is a del d by del L. Now here from this Poisson's relation you calculate this del d by del L. Now your job is to rearrange this equation number 2. So here in the second term I am basically doing some substitution. I am rearranging the term and doing this substitution del d by del L. See how? So here let me, this is the step number 5. Let me write this is step number 5, right? Step number 5. So in step number 5, from equation number 2 I will write 1 by r del r by del s equal to 1 by L del L by del s minus 2 by d del d by del L. See, I am writing this del d by del s as del d by del L into del L by del s. I can write it. Alright, I can write it. See what I did, del d by del s, in place of del d by del s I am simply writing del d by del L into del L by del s. So del L, if you cancel out this you will get the same, del d by del s, right? Del d by del s. So now in place of this del d by del L, del d by del L, you simply write Greek letter this V into d by L, right? So the same I am going to do. 1 by r is equal to 1 by r del r by del s is equal to 1 by L del L by del s plus 2 by d Poisson's ratio into d by L into del L by del s, right as it is, plus 1 by rho del rho by del s, right as it is. Now del s is in left hand side and del s is in right hand side. So just ignore this del s or you cancel out this del s in right hand side on left hand side. So you will get del r by r is equal to del L by L plus 2 Poisson's ratio del L by L plus del rho by rho, right? Alright, so simply you will now you can simply write this, for a small variation, for very small variation you can simply write this delta r by r is equal to delta L by L plus 2 times of Poisson's ratio into delta L by L plus delta rho by rho, right? So on both side divide by epsilon, which is nothing but a strain, that is delta L by L. So you will get del r by epsilon into r is equal to, so when you divide it by epsilon, that is delta L by L, here you will get 1, in very first term you will get 1, right? Alright, plus 2 rho del L by L get cancelled, right? Del L by L get cancelled from here and here, so 1 plus 2 rho, plus here you will get del rho by rho into epsilon. Alright, so that you will get. Now I am representing this del r by epsilon r by another letter GF, right? So I am denoting this del r by r into epsilon by a letter G suffix f, that is basically gauge factor. So its simple notation, gauge factor, that is G suffix f, that is basically del r divided by delta r divided by r into epsilon, that is GF. It's a simple notation. I am simply noting down this del r by r into epsilon by another letter G suffix f, which is known as gauge factor G suffix f, GF. Gauge factor GF is equal to 1 plus 2 into gauge factor 2 rho plus delta rho divided by rho into epsilon, right? Rho into epsilon. All right. So this very first term, this is 1, that is basically it is representing change in resistance due to change in L, right? This is the first term, which is the representation of change in resistance R due to change in length L, right? Now this second term is basically, this is the change in resistance R due to change in area, capital A. The second term, 2 into Poisson's ratio, this is representing change in resistance R due to change in area, plus this third term is basically representing change in resistance R due to change in resistivity rho, right? So gauge factor, right? So this is a gauge factor is equal to 1 plus 2 into Poisson's ratio plus del rho by rho into epsilon, right? So if you ignore this third term, considering that the change in resistance are due to change in resistivity, it is very small, almost negligible, then you can ignore this third term, and finally you can write this gauge factor GF is equal to 1 plus 2 into Poisson's ratio, right? That is the final relation that you obtain. So this is valid only for piezo-resistive effect. All right, that's clear. So GF is equal to 1 plus 2 into this Poisson's ratio, right? After neglecting this third term. All right. So GF is basically gauge factor that we have defined that it is delta R by R into epsilon, delta R divided by R into epsilon, delta R divided by R into epsilon, delta R divided by delta R by R, delta R by R into epsilon. Epsilon means it is delta L by L, delta L by L, right? That is the value of gauge factor. All right. So on this you can have some small numericals which is important for the exams for GATE and engineering service. All right. So the derivation is simple. The only thing is that you should keep these steps in your mind and just have a look at it. Just practice this, you will easily be able to derive this. Now let me go for a small numerical.